Welcome to the Future of Structures podcast, where we talk to the experts who are evolving our buildings of tomorrow. And here is your host, Adam Jones.
Hey guys, today we interview Michael Lord. So Michael Lord is the head of research at Beyond Zero Emissions. Now, Beyond Zero Emissions have the ambitious goal, which is super important for obvious reasons, of getting Australia to zero emissions within 10 years. So Michael is well aware and well informed about the dangers if we don't reach these goals. So his life's mission has been how to get the world to zero emissions to limit the effects of global warming. So Beyond Zero Emissions have already done a whole bunch of different kind of reports, including one on the land use, buildings, electricity, and a lot of different areas where carbon is most commonly found in our industry. But today's episode is focused on their newest report, which is going to be on industrial processes. And today's episode is specifically on cement. Now, I had no idea how big the impact of cement was on global emissions. Who would have thought that it is 8%, which is greater than the contribution of cars by themselves? So this report, there is 5 different strategies to eliminating our, addiction to cement. And listen up, there's a lot to learn, and this kind of work hasn't been done before. So Beyond Zero Emissions are at the forefront of our fight against climate change. And listen in, and most importantly, whatever you learn, if you're an engineer, or if you're an architect, or whatever you're doing in the buildings industry, try and take something from today's episode and take action, because it is everyone's responsibility to tackle climate change. So guys, I hope you enjoyed this episode as much as I did speaking to Michael. He's a great guy, he's really driven, and he's doing a lot in his effort to try and minimise the effect of global warming.
First of all, thanks for having me on the show. I'm pleased to be on it. I was actually originally a software developer and morphed into doing project development, project management, and business analysis alongside software development. But I was also interested in the environment and issues affecting the world, particularly climate change, and becoming quite concerned about it the more I read about it. I guess I'm talking about 12 years ago.
Yep.
And really wanted to work in this area and had read up a lot about it. I'd recently moved from Britain to Australia and managed to get a job for the Victorian government working in the climate change team. And at that time, the Victorian government was doing some very interesting things on climate change, and they were the first to legislate for an emissions reduction cut in the Climate Change Act at that time.
Yeah, and now you ended up at Beyond Zero Emissions and the head of research now, and you've done, how many reports has Beyond Zero Emissions done?
Yeah, so but the aim of Beyond Zero Emissions is to show that using current technology, getting to zero emissions is achievable and affordable. So we're showing that by taking each sector in Australia that produces emissions and showing that it can get to zero in 10 years using commercial technology. So I think we've done about 6 major reports and some smaller ones. And those reports have covered, the first one, which made a big splash, was on electricity, called the Stationary Energy Plan. That was in 2010. And it showed, it was the first detailed report in Australia to show that we could have a fully renewable electricity system. And at the time, that was very radical, even within the environmental movement. But since, I think we've been shown to be right. Subsequent reports have shown that it's possible, and it's actually become a lot easier since we issued the report because of the drop in price of both wind and solar. We've also had reports on buildings, land use, aspects of transport like electric vehicles and high-speed rail, and now we're tackling industry.
Yeah, so I guess it's probably worth mentioning now a bit like why it's so important right now. So what do you think, if Beyond Zero Emissions don't, or if the whole society doesn't achieve these goals, what do you think the future could potentially look like if if we don't go down the route or the advice that has been provided in these reports?
So we need to reduce emissions to zero, and the reason for doing that is that as long as they're above zero, we're exacerbating climate change and the planet will continue warming. And what all governments in the world have decided, it's somewhat arbitrary, but they've decided that a level of warming of 2 degrees centigrade is dangerous. That's the threshold for dangerous climate change. We're already at about 1 degree, and another, let's say, half a degree is built into the system, whatever we do now.
Yeah.
So I think it's quite well known that a lot of the impacts that will happen, there'll be sea level rise, and a large percentage of the world's population lives only just above sea level. So a lot of great cities and large areas of land will be flooded by the sea level rise. There'll be changes in rainfall patterns. So, for example, some areas that don't get much rainfall now will get even less rainfall, which will affect food production. Glaciers will melt, and a lot of major rivers in the world, particularly on the Indian subcontinent, are fed by glaciers. There'll be more extreme weather, stronger cyclones, heavier downfalls of rain. So it's a very long list of negative impacts, and I guess the overall thing to say is that it will affect humans and all other species on the planet in a negative way if we let climate change run away and it doesn't just stop at 2 degrees. If we do nothing about it, it could go up to, say, 5 degrees or more by the end of this century.
Yeah, and I guess that just sounds scary just hearing about it. And if we just could picture what all that, in a scenario of 30 years from now, maybe we'll move a bit quicker. Do you think we're actually moving fast enough right now, bear in mind that, what could potentially be coming to everyone on the earth?
We're certainly not moving fast enough. We've got a carbon budget of, if I get this right, about 600 billion tonnes of carbon dioxide is what we're able to release more. And that will be gone in about 15-20 years at current rates of emission. So we at this moment we need to be rapidly decreasing greenhouse gas emissions. The reality is that we've in the last few years managed to keep them more or less stable, which is obviously a start before you start to decrease them, but we need to quickly start decreasing them. And beyond zero emissions, really, an interesting thing about, although you said you find that frightening, that list of impacts from climate change, and they are frightening. An interesting thing is that the effect on most people is probably also to be frightened, but then to feel overwhelmed and think, well, we can't do anything anyway. So what Beyond Zero Emissions really focuses on is not the climate science or the impacts, but the technical solutions that are available.
Yeah, I guess that's the positive part, and having Beyond Zero Emissions there, we can see what the solutions are, and when eventually we get a big enough scare, we'll inevitably hopefully use these reports that we've been working on to find the solutions.
You'd hope so.
So the latest report that Beyond Zero Emissions are releasing is the Industrial Processes report. Can you tell us a little bit about where that sits in the others and the relevance of this report and how big an impact it might have on the industry? Yeah,
so the industry or industrial processes, we're talking about the production of everyday materials such as metals and plastics and glass and cement. And this is really the last big sector that produces emissions that Beyond Zero Emissions hasn't tackled. But it's a really important one because it produces about a fifth of emissions in Australia and worldwide more like a third. But it doesn't get discussed to as much as it deserves. Industry is quite unseen by most people. Most of us don't work in manufacturing, and we don't experience how these products are produced on our behalf. But they do cause a lot of emissions. Some of those emissions will be removed as we move from fossil fuel generated electricity to renewable sources of electricity. But the majority of emissions in industry are not to do with electricity. They're to do with either the heat that's required, and usually it's gas or coal that's burnt to get that heat, or process emissions. By process emissions, I mean the chemical reactions that occur as an integral part of the manufacture of some products.
Yeah. Does 1/3 of all emissions come from this report, and it hasn't really been touched on? Is that roughly?
I wouldn't say it hasn't been touched on at all, but it's been neglected.
Compared to
say electricity production, which gets the lion's share of the debate.
Yeah.
Sometimes people talk about transport and things like electric vehicles, but industrial production is not discussed very much.
I guess that's exciting if people listening want to see like the opportunities. So there was so many innovations or new technology in transport and electricity, and maybe there'll be new materials or new other industries that might benefit from what's to come with industrial processes.
Yeah, that's right. And one of the objectives of our report, in fact all our reports, is the main objective is to reduce emissions. But our argument is that this is the way the world's going. This is all governments agreed in Paris that we'd limit global warming, which means reducing emissions to zero. So that this is going to create new industries and economic opportunities of the future. So all the technologies that we talk about in our reports are also opportunities for Australia to lead if we choose to do that.
Yeah, definitely. So in the industrial process report, is the biggest or one of the big ones that Beyond Zero Emissions is tackling is cement. So perhaps can you just start off by telling us a little bit about cement in the report?
The first part of our zero carbon industry plan is going to be on cement, and we're actually going to release that report called Rethinking Cement next month. And the reason we've chosen cement is that it contributes to 8% of greenhouse gas emissions, and that's more than all the cars in the world.
Yeah.
And not only does it contribute that much, 8% of greenhouse gas emissions, but the majority of those emissions are not related to energy, but to the chemical reactions that occur when you make cement. So cement is made by taking calcium carbonate, which is usually limestone. You heat that calcium carbonate to a high temperature, and when that happens, it decomposes and releases the carbon dioxide that it contains. So that process that takes place within a cement kiln, just that one process is responsible for more than 4% of world emissions. So it's something that needs to be tackled as we move towards zero emissions as a planet.
Yep. So the report has 5 different strategies to tackling cement. Can you start off by going through the first strategy to eliminating our, addiction to cement?
Yeah, that's right. We've got a pathway of 4 or 5 strategies which takes us to zero emission cement for Australia in 10 years. So the first strategy is about geopolymer cements. These are an alternative type of cement which are not based on that process that I just described of heating limestone. They're made with they can be made with a variety of materials like fly ash from coal-fired power stations, slag, which is a byproduct of making iron. They can also be made with types of clay and volcanic rock. And they contain a sort of magic ingredient which is called an alkali activator, which is a strongly alkaline solution, which turns the raw materials, allows the raw materials to become the binder, which makes them useful as a cement. Now, geopolymer cements are a very small part of the cement market at the moment, but we do have several decades of experience with them. So the first geopolymer cement concrete buildings were put up in what's now Ukraine in the 50s and 60s. And they built some pretty high-rise buildings with them, which are still going strong today. And a lot of the more recent experience has actually been in Australia. So the newest airport in Australia, Brisbane West Wellcamp Airport, was largely built with geopolymer cement concrete by a company called Wagner's. Yep. They also built a multi-storey building at the University of Queensland using their geopolymer concrete. And there's a company, one of the global pioneers in geopolymers, is based in Victoria, called Zeobond, and their product Ecrete has been used in 40 or 50 projects in and around Melbourne.
40 or 50, wow. So you mentioned multi-storey buildings. So what is the strength that geopolymer cements can actually achieve?
Geopolymer cement can really be used to make any type of concrete that we need for any use.
Yeah.
So the strongest one that I know of is a clay-based geopolymer made by a UK-based company called Banner. They produce a clay-based geopolymer called Banner Cem, which has strengths up to 135 MPa. So that's as strong as you're going to need.
135 MPa.
Yeah, which is as strong as you're going to need for nearly any purpose. Probably too strong for most purposes. And the reason we're so interested in geopolymer cements is that it has far lower emissions than regular Portland cement. So as they're manufactured today, they have 80 to 90% lower emissions. That's because they don't require the heating of limestone, and they don't require any reactions that give off carbon dioxide. If we had zero carbon sources of electricity and of energy, then they could be made. They could be zero carbon cements.
Yeah, wow. So this is probably going a bit off topic. It was some of the older buildings in Rome back in the day. Am I right in thinking that they weren't using Portland cement back then, and then some of those structures are still there today? Is that right, or you know?
Yeah. The Romans were big users of concrete. And so for their sort of grander buildings, they used volcanic ash in that concrete. They mixed it with lime. So things like the Colosseum and the Pantheon are made with this cement. And those cements are like a combination of regular Portland cement, but they also share some characteristics with geopolymer cements, in that they use this volcanic ash, which has a property which is called which we now call pozzolanic, and that's also the property we look for when making geopolymer cements. Yeah,
wow! It just shows how durable they can be. And for the second strategy, can you tell us a little bit about using the high blend cements?
Yeah, so we envisage geopolymer cements accounting for 50% of the market in 10 years' time. The other 50% we envisage being covered by what we call high blend cement. So that's a term we've coined for the reports. And what we mean by that is that the what's called the clinker in cement is replaced to a very high degree. Clinker is this limestone-based product that we've spoken about, which makes up the majority of cement. But cement companies have increasingly started to replace the clinker with other materials such as fly ash and slag. And in Australia, they've now got to the level where about 30% of the clinker is replaced. And that leads to a reduction in the cement-related emissions, so it's a good thing. And we think that the level of those replacements can be increased to an average of 70%, leading to a big reduction in the emissions from cement. So that 70% would be mixtures of mainly fly ash, but also iron slag and ground limestone. And new technologies such as new grinding technologies are making this high clinker substitution possible.
Yep. And what are some of the effects on the actual cement or concrete compared to Portland cement, which industry is used to at the moment? Is there some positives, and and some negatives, or?
Well, the big positive is the reduction in emissions. We've got quite a few examples of high blend cements being used in projects around the world. Some of them even as high as the 70% we're aiming for in 10 years. And in fact, Boral, Australians, one of the big three Australian cement manufacturers, has a cement product, a cement called Invisia, in which they can already replace up to 80% of the clinker, in that case using slag.
Yep.
We're relying more on fly ash as the substitute, and there are examples from around the world of fly ash being used to replace up to 70% of clinker, and we're also relying on ground limestone. And there are examples going back a very long time to the big dams built in the US in the 1930s of a lot of ground rock, up to 50% of clinker being replaced with ground rock.
Yep.
One of the disadvantages if we use a lot of fly ash is that the setting of the cement takes a bit longer.
Yep.
And that's a disadvantage because although the concrete achieves the required strength, it takes longer and can delay construction times, which would often lead to higher costs. So that's one of the things that needs to be worked on when we use a lot of fly ash. How do we speed up the setting and hardening time?
Yeah, awesome. So I guess I probably should have covered it with strategy 1 as well, but for both geopolymers and high blend cements, has Beyond Zero Emissions also looked into, I guess, sourcing the materials as well, and I guess the pathway into industry being able to supply it to engineers?
Yeah, that's a really good question. When you're talking about cement, because we make so much of it, I mean, Australia makes only a tiny percentage of world cement, but there's still 12 million tonnes required a year in Australia, and that's compared to 4 billion tonnes around the world. So whatever solution you come up with, you've got to have enough of the raw material, and it's got to be abundant and cheaply available. So we've definitely considered that as we're looking at the report. The main material we're relying on is fly ash. We're relying on 5 million tonnes of that being available every year. But the crucial thing is fly ash is a byproduct of burning coal in a coal-fired power station. But the crucial thing is we don't need those coal-fired power stations to continue operating to produce our fly ash, because one of the legacies of having coal-fired power stations for 100 years in Australia is that we've got hundreds of millions of tonnes of it sitting around in landfills. Now, while you need to process that landfilled fly ash before you can use it in cement, you might need to dry it, for example. You can use it, and companies in the US and Europe are beginning to use the stockpiles there for use in cement. And what we're saying in the report is we should see these stockpiles as one of our great mineral resources. They also at the moment present a kind of environmental and health hazard, so putting them in the cement is a win-win outcome.
Definitely. And the third strategy we'll get into now is carbon mineralisation. So what actually is carbon mineralisation?
Yeah, I don't think many people will have heard of this technology, but one of the outcomes of our first two strategies is that we're still left with about 15% of the emissions coming from a cement kiln, because we're still producing some of this Portland cement clinker. So carbon mineralisation is a way of dealing with those emissions. So what happens in that process is that you react the carbon dioxide emissions at the cement kiln with another substance. In the case we're talking about, it's a magnesium silicate, and the magnesium silicate reacts with the carbon dioxide to make magnesium carbonate. And magnesium carbonate is a rock. So what it means is the carbon dioxide is chemically sealed within a rock and will stay there forever. one of the good things about this process is that it produces, doesn't just absorb the carbon dioxide, but it produces products which have a commercial value. So magnesium carbonate itself can be sold as a road base or a fire-resistant building material. And the process also produces silica, which has a number of commercial uses.
And just quickly, and how is this different to, I know it's completely different, but to carbon capture and storage, because it seems a little bit similar in a way.
Carbon capture and storage is more well known. So the first part of the process is similar in that you're capturing the carbon dioxide, but with carbon capture and storage, you're then transporting it to some kind of geological formation. People often suggest a depleted oil field, pumping the carbon dioxide underground and then storing it there, you hope, for forever. This has been discussed a lot as a solution to fossil fuel fired power stations. The problem with it is we just don't think it's going to happen. It's too expensive, it doesn't have any commercial value, it only adds to the cost of a process. And while the coal industry has been saying it's a solution to them for more than a decade, it's rarely been implemented, and so we think that the cement industry is even less likely to implement it. And you need the presence of this geological formation where you're going to store your carbon dioxide, whereas with carbon mineralisation, you're producing something with commercial value, so you can see a route to it being financially positive.
Yep, awesome. And another one of the strategies to reducing cement was using less. So can you tell us a little bit about the using less part of the strategies?
Yeah, so we've got the easiest way to save the emissions from cement is just not to use it in the first place. But there's only so far we can go with that. So we've got a couple of complementary strategies which we think we can use just to avoid any growth in the use of cement in Australia. One of those is just smarter design. So we could do a lot more thinking when we build structures into how much concrete goes into those structures. We could put a lot less concrete in them. We could use new building optimization software to ensure we minimise the use of concrete in buildings, and if we minimise the use of concrete, we reduce the use of cement.
Yeah.
The other thing we could do, which is really exciting, is to start using timber more to build buildings. So there's a new generation of timber products, things like cross-laminated timber and laminated veneer lumber, all sorts of timber products which can be used to build buildings at least up to 20 stories. So pretty much any kind of building we build today, apart from very tall skyscrapers, can be built with timber. And when we do that, we know that we replace at least 60% of not just the concrete but also the steel, which makes that structure much less carbon intensive. There's far fewer embodied emissions, and in fact using timber actually stores carbon within the wood. So when we're growing the trees, we're withdrawing carbon dioxide from the atmosphere and we're storing it in the timber for buildings. So we think we should use as much timber as possible to build structures in Australia.
And I guess some people, when they hear about timber, they think, we're cutting down forests and all that, but this is sourced sustainably, so it's in like timber plantations where it's grown in the same spot for years and years, and then the timber's just stored in the one plank of wood, and it has a positive impact on the environment. Yeah,
that's a really good point, Adam. We would absolutely oppose the cutting down of any native vegetation in Australia or elsewhere to get this timber. Yep. The way to get it, and it's much more efficient, is to grow plantations, to specifically to treat it as an agricultural crop, to grow trees such as pine trees, which are very fast growing. And you can do that today in Australia. There's plenty of land which is already cleared which is either not productive or very little productive. And what we're saying we should do is incentivise the timber industry in Australia to grow and make more buildings out of it.
And I guess also as a structural engineer, there's huge advantages with timber, and that's on, I guess, buildings where weight might be an issue. So if you've got bad founding conditions, or if you've got an existing building, there's opportunities in using timber there. And I guess the other one is speed of construction. Yeah, have you got anything to add to that?
No, only that you're right. And in the examples that we present in the report, that speed of, although timber's more expensive at the moment than concrete and steel as a construction material, overall there's cost savings precisely because of that speed of construction.
And I guess speed is the most expensive thing on a lot of projects. Like you mentioned at the start, that efficiency is a problem with using cement, just because engineers get paid by the hour and then they have to be efficient with their own time. So I guess any time saving is probably the biggest thing developers are looking at in their developments.
Yeah, and timber's great for that because all the pieces are cut precisely off site, and then on site it's just like a 3D jigsaw for a few skilled carpenters.
And just finally, quickly on the fifth strategy, carbon negative cements. Can you tell us a little bit about how they work in strategies?
Yeah, sure. So the first four strategies are what takes us to a zero carbon cement industry in 10 years. We put the fifth strategy in there as a longer term thing, which is really tantalising in a way, because it may be possible to make carbon negative cement. So that's cements where in making them, they actually absorb carbon dioxide from the atmosphere. So the most likely way of making these cements is to make them magnesium-based cements based on magnesium silicate rock, similar to the way we'd do carbon mineralisation, which we spoke about. They haven't been commercialised yet. A couple of companies have tried, but we think it's something that's certainly worthy of more research, and that government should put research effort into carbon negative cements.
Yeah, unreal. So those 5 strategies, I guess, all sound very possible and for the whole cement industry or the whole buildings industry and anyone involved with cement to tackle that 8%. So where can people find Beyond Zero Emissions, and if they wanted to support the organisation, how can they do that?
Yeah, well, it's worth saying that we rely almost 100% on donations from members of the public, on people that support what we do. So if anyone wants to donate to us, either a one-off donation or to become one of our regular donors, they just need to go to our website, which is bze.org.au. There's a donate button there, and just follow the links.
Yeah, unreal. All right, thank you, Michael, and looking forward to all the work Beyond Zero Emissions are doing in the future also.
Thanks, Adam.
Cheers. Hey guys, just before you go, one quick request. If you're listening on iTunes, please leave a review. It helps our ranking on iTunes so more people can find us and more people can listen to the experts who are changing our buildings for the better in the future for a sustainable planet. And if you don't want to leave a review, just hit subscribe so all our episodes just appear magically in your iPhone every single week and you won't miss a thing.